For some reason, a surprising number of people today truly believe that modern Earth is the absolute worst place humans could be living in. They're fed up with the way the weather keeps flipping back and forth, one day freezing and the next boiling, forcing them to bundle up in heavy coats or strip down to almost nothing just to stay comfortable. And it's not just the climate that bothers them. They're not too fond of today's animals either. Venomous snakes, crocodiles with rows of razor-sharp teeth, stinging bugs that come out of nowhere. The list goes on. These folks often say things like, "Back in the old days, the air was clean, the weather was perfect, and all the animals were kind and harmless." Sure, the Mesozoic Era brought massive, terrifying dinosaurs into the picture, but they argue those creatures went extinct pretty quickly. And before that, Earth was supposedly only home to tiny, harmless critters that looked like fuzzy little mice. Do you believe that too? If you do, then go ahead and hit that subscribe button right now. Or maybe you're thinking, "No way, that's totally wrong." In that case, you've probably already subscribed, haven't you? Hey there, everyone! But if we were to toss those nostalgic dreamers into a time machine and drop them off in the pre-dinosaur era, that sweet fantasy of Earth as a paradise would probably shatter the moment a Gorgonops came lunging at them from the shadows. From its fiery birth all the way to the end of the last ice age, Earth's history has been almost nothing but a non-stop chain of disasters, like a 4.5 billion year-long horror series that just never lets up. Welcome to our channel. Let's dive right in. From scorching heat to freezing cold. Before the age when dinosaurs came to dominate the oceans and the land, Earth had to travel a long, harsh, and unbelievably dangerous road to get there. In the beginning, before there was even a sun, before Earth or any of the other planets existed, the infinite void of space was filled with enormous clouds of gas made almost entirely of hydrogen and helium atoms. If it hadn't been for a few nearby supernova explosions on a cosmic scale, those gas clouds might have just kept drifting forever, aimless and unchanged. But the shockwaves from those powerful blasts violently compressed the gas, rapidly heating the center of the cloud until it reached the point where nuclear fusion finally ignited. And just like that, around 4.5 billion years ago, the sun was born and began to shine for the very first time. But it wasn't anything like the calm, steady sun we look up at today. Back then, it was wildly unstable and gave off far less heat than it does now. So, what about Earth? What was happening to our planet around that time? Well, right then, Earth was just starting to take shape, forming from the same cosmic dust and gas, slowly flattening into a spinning disk. That swirling disk began pulling in nearby dust, tiny fragments, and even asteroids, gradually gaining mass until it eventually developed a solid, metal-rich core. Intense gravitational pressure heated that core to extreme levels, reaching temperatures as high as 11,000 degrees Fahrenheit, while a surrounding layer of liquid metal started to form. The movement of that molten metal around the solid inner core created swirling currents, generating a kind of natural dynamo deep inside the planet. That dynamo gave birth to Earth's magnetic field. And that magnetic field, even today, acts as a vital shield, protecting our delicate lives from the brutal radiation constantly pouring in from outer space. Of course, back then, there wasn't a single living thing around to protect. Earth at that time was nothing more than a blazing sphere of molten rock, a hellish ball of magma. And right in the middle of all that chaos, young Earth experienced its very first planetary catastrophe. It was drawn into a collision course with a nearby protoplanet, a world scientists later named Theia. That impact blasted out an incredible amount of debris, and over time, those pieces clumped together to form the mysterious companion we now call the Moon. So maybe there's some truth to the idea that we find our life partners through a little cosmic collision. Fascinatingly, after that massive crash, Earth's rotation sped up so much that a full day lasted just 5 hours. But over hundreds of millions of years, the Moon's gravity gradually slowed Earth's spin, stretching those days back out toward the 24-hour rhythm we now know. Still, even then, Earth was nowhere near a place you would call livable. Not just for humans, but even for dinosaurs, that kind of world was nothing more than a distant dream. Back then, Earth was flooded with rivers of lava, bombarded from above by a relentless rain of meteors, and completely hostile to anything even remotely resembling life. It looked more like Venus does today, cloaked in volcanic fury and constantly drenched in acid rain. And yet, incredibly, around 3.7 billion years ago, life somehow appeared on this unforgiving planet. These first forms of life were single-celled microorganisms that didn't need oxygen, which makes sense because Earth didn't have any oxygen at all back then. For over 2 billion years, these simple life forms slowly built up calcium-rich structures called stromatolites in warm, shallow coastal waters, leaving behind ancient geological traces that still survive from the Archean Eon all the way to today. The most primitive of these organisms didn't even have a nucleus inside their cells. But because of that incredibly simple design, they're still with us today, thriving in boiling hot geysers, in freezing cold waters, and even in the most acidic environments on Earth. If there's ever been a perfect example of slow and steady wins the race, this is it. And over time, some of these microbes figured out how to do something revolutionary. They learned to perform photosynthesis. At first, the oxygen they created just got absorbed by iron-rich rocks. But around 2.45 billion years ago, the oxygen started building up and finally leaked into the atmosphere, triggering what's now called the Great Oxidation Event. For life forms that didn't rely on oxygen, this gas was pure poison. Earth went through its first massive biological disaster, and many of the early life forms that perished in that event eventually became the world's very first sources of hydrocarbons. By the start of the Proterozoic Eon, about 2.46 billion years ago, oxygen made up 2% of the atmosphere, which is just 1/10 of what we breathe today. That's 3 times lower than the oxygen level on the summit of Mount Everest, where climbers need to wear oxygen masks just to survive, and that's only around 7%. So if you were somehow transported back to early Proterozoic Earth without a mask, you'd probably suffocate in minutes. And that's without any T-Rex charging at you. It's terrifying enough all on its own. Before all of this, Earth's atmosphere was completely dominated by methane and carbon dioxide. These gases were already triggering the thing we now fear so much, the greenhouse effect. But, oddly enough, back then, that very effect was what kept the planet warm enough to stay habitable. When oxygen began reacting with the methane, though, it ate away the greenhouse gases, weakening their effect and sending Earth's temperature into a steep decline. So even though the oxygen levels were going up, that didn't make things more comfortable for life like us. On the contrary, we would have frozen to death. That's because Earth was plunging into the longest glacial period in its history, the Great Huronian Glaciation. It lasted for a staggering 300 million years, transforming Earth from a world that once looked like Venus into a frozen wasteland, with temperatures in some regions dropping to between -4 and -94 degrees Fahrenheit. There was absolutely no way complex life could have evolved under those conditions. And yet, against all odds, a few resilient microbes like cyanobacteria and archaea managed to cling to life through it all. You'd think that life had hit a dead end, stuck forever at this primitive stage. So, how in the world did dinosaurs, or humans for that matter, ever come into existence? The answer lies in one familiar force: the sun. Over the 300 million years that followed the start of the Ice Age, the sun gradually increased its heat output, melting much of the planet's thick frozen shell and opening the door for the rise of multicellular life and complex plants. And from that moment on, everything began to change. Over the next billion years, life on Earth grew more and more diverse, branching into countless forms. But the real turning point was when living things finally made the leap from sea to land. By the way, when Earth warmed up again during the Carboniferous period, it was like something out of a roided-out zoo. Around 300 million years ago, long before any dinosaurs set foot on the planet, Earth was crawling with massive insects and giant spiders that looked like they'd come straight out of a horror movie. The hot, humid climate and atmospheric oxygen levels that climbed as high as 35% helped arthropods grow to mind-blowing sizes. Picture dragonflies with wingspans almost 3 feet across, or gigantic millipedes that slithered along the ground stretching over 8 feet long, nothing like the tiny ones we see today. Back then, some spiders were the size of house cats, and even the bravest scientists today would probably shudder just imagining them. The creatures roaming Earth at that time were like living special effects in a sci-fi movie. Except there were no cameras, no crew, and definitely no pause button. And it wasn't just life that was on the move. The land itself never stopped shifting. Around 750 million years ago, the supercontinent Rodinia began to break apart. Those scattered pieces drifted across the ocean and eventually came together again to form a new landmass, the supercontinent Pannotia. But Pannotia didn't last forever either. It broke apart once more, and as those fragments kept moving, they crashed into each other again and again, giving rise to massive mountain ranges. Then, about 335 million years ago, all those drifting pieces finally came together again, forming one colossal landmass, the supercontinent Pangaea. And that enormous block of Earth would later break apart and give rise to the continents we know today: Africa, Eurasia, and the Americas, both North and South. The Great Permian Extinction. Most people, even kids, probably know the story of why the dinosaurs went extinct. The usual explanation is that a massive asteroid slammed into the Earth and wiped them out. Scientists have even pinpointed the exact location of the impact crater. It's in the area around the Gulf of Mexico. But far few people have ever heard about the Great Permian Extinction, which marked the boundary between the Paleozoic and Mesozoic eras. And yet, that event was actually the largest of the 5 mass extinctions ever recorded in Earth's history. We often say that if the dinosaurs hadn't gone extinct, humans might never have appeared. But the truth is, if the Permian extinction hadn't happened, dinosaurs themselves might never have existed. And yet, leading up to that catastrophe, there were no signs at all that another major disaster was looming. During the Permian period, 2 major groups thrived for nearly 40 million years: the sauropsids, ancestors of modern reptiles, and the synapsids, which would eventually lead to mammals. In fact, the synapsids were starting to show real evolutionary promise, the kind of progress that could have eventually led to intelligent life. But that evolution was abruptly cut short, which means that we, Homo sapiens, didn't just come into existence because the dinosaurs disappeared. We also owe our existence to the Great Permian Extinction. That distant Permian world, long before dinosaurs arrived, was a rich time for the evolution of plants and animals, but it was absolutely not a place where humans could have survived. In fact, it was quite the opposite. The climate overall was dry, with regional variations that somewhat resembled the way our climate works today. But the atmosphere? It was loaded with gases that would be downright toxic to us. While oxygen levels were actually 1% higher than they are now, carbon dioxide levels were 3 times greater than what we deal with today. In that kind of air, you wouldn't just get a splitting headache, you'd likely black out from carbon dioxide poisoning. And by the end of the Permian period, CO2 levels had skyrocketed to a shocking 12 times what we see now. Sure, crews aboard German submarines were trained to tolerate similar CO2 concentrations, so maybe we could have adapted too, but at what cost to our bodies and brains? Still, even harder than adapting to the air would have been getting used to the animals that ruled the land and sea back then. The oceans were filled with enormous sharks and bony fish swimming through the water. On land, there were small mammals, massive herbivores like Scutosaurus, and terrifying predators like Gorgonops, distant relatives of modern mammals. Gorgonops looked like something between a dog and a dinosaur, and it was every bit as dangerous as crossing a pit bull with a T-Rex. It had a dog-like shape, but it was hairless and stretched over 10 feet long, a monstrous beast by any measure. And from its ancient jaws jutted out a pair of huge, saber-like fangs built for tearing prey apart. You wouldn't have much hope if you ran into one of these predators. And yet, scientists consider them early ancestors of mammals, which means, unbelievably, they're part of our extended family tree. Still, even these fierce creatures were completely wiped out by the end of the Permian. According to paleontologists, around 96% of marine life vanished in that extinction event. And on land, the destruction was even more catastrophic. For the only time in Earth's history, even insects couldn't escape. Up to 80% of all insect species were lost forever. About 70% of all land-dwelling vertebrates, including gorgonops, also disappeared. From a geological perspective, this mass extinction happened incredibly fast, in as little as 60,000 years and no more than 200,000. Most scientists believe it was triggered by an immense series of volcanic eruptions that unleashed floods of basaltic lava. Those lava flows eventually formed the massive region we now call the Siberian Traps. The eruptions poured hundreds of millions of tons of sulfur dioxide and carbon dioxide into the atmosphere, poisoning the oceans with sulfur compounds. As a result, Earth's temperature soared, and atmospheric CO2 levels spiked from 400 parts per million to an astonishing 2,500. All of this took place right at the boundary between the Paleozoic Permian and the Mesozoic Triassic, just before the dinosaurs made their grand entrance. So, in a strange way, it was the Great Permian extinction that cleared the stage for both the plant-eating and meat-eating dinosaurs that would follow. And maybe, just maybe, compared to the monsters that came before them, the dinosaurs weren't all that scary after all. If you enjoyed this video, be sure to give it a like and share it on social media. Thanks so much for watching. Until next time, take care and goodbye.